Hi, I am Prashant. This is my internship work for the Spark Foundation. The task is to predict the species of the iris flower with some visualization effects. The iris flower is a name from the Greek goddess of the rainbow. This is the image of the iris flower as you can see here. So what is the data given to us? The data is of sepal length, sepal width, petal length and petal width. And what we have to do, we have to predict the class or the species of the flower. So these are three types of species which are given into the data. This is Iris setosa, Iris versicolor, Iris virginica, and this is the sepal of the flower. This is the petal of the flower. The dimension is given of the two entities, and we have to predict among based on that. So we are importing models. We have imported first the basic models for the NumPy and pandas, which are required for the NumPy. Then we ignore warnings. That's why I import warnings and remove the warnings. For visualization purpose, we use C1 library as well as Matplotlib library. And for preparing our machine learning model, we created random forest, decision tree, k-neighbors, logistic regressions, and imported it from the scikit-learn library. After that, we loaded the data from the iris.csv file to our data variable. Then we visualize the data like this, and the data contains ID, sepal length centimeter, sepal width centimeter, petal length centimeter, petal width centimeter, and the species names. After that, if we see data to describe, then there are some mean max values are being given over there. So 7.90 is the maximum value of sepal length, whereas 4.44, 6.90, 2.5 with respect to that. So if let us check for the null values, if there is any null value, then we have to remove it. So let's check about that. So when you are checking, then we got that there is a no null value. So that's a very good thing. So we can move forward and we can check for the outliers. So we plot here box plot using this C1 library. Here we can see that there is no outlier in sepal length. We check for the sepal width, then there we can see there are four outliers over there. And for same for the petal length and petal width, there are no outliers. So these are our observation that there are no outliers in sepal length and petal length. But whereas sepal width have just four outliers, so we can neglect it for the time being. And let's see the encoding to the target parameter, which is species. We have to encode the species parameters. So if we see there are how many unique values, then there are three unique values, which is three different classes: Iris setosa, Iris versicolor, Iris virginica. So after that, we have to I use the map function over there to map it and to change the string values into the numbers, because our machine learning model does not understand strings, it just plays with numbers. So after that, removing, we also I also remove the ID value, because there is no use of ID to predicting the class, because what is the number of that, it doesn't matter. After that, we see the heat map, where you can see the correlations between the class, different dimension with respect to species. Here in this column, you can see there is a 0.96 correlation with petal width of the species. In here, 0.95, which is too high with the compared to the others. So definitely, the observation is petal dimensions are highly correlated with species, as we can see over there. After that, I plotted some use graphs which is gives a clear indications. Over iris, there are three different species: Iris setosa, Iris versicolor, and Iris virginica. And this is scale in centimeter. So what observation we can mention here? While the range of petal, this is blue line is for petal width, and when there is a 0 to 0.5 somewhere, the petal width, then the flower belongs to the Iris setosa species. And when it's greater than 2.5 to nearly 2, then it belongs to the Iris versicolor. And it's when it's 1.2 to 2.5 and beyond, then it becomes the Iris virginica class. So these are the very good observations we can made from this graph. This graph is useful, and definitely petal dimensions are specifying us more clear indications that which is this flower is going to belong to the which species. After that, we have to prepare input and target data. So for that purpose, I dropped the species column from our original data set, and I put it into the input parameter variable, and then data species variables into target parameters. So this is input parameters, the dimensions, and target parameters, the species. After that, I have checked out the values, what are the shape of the both of the target parameters and input parameters. After that, we have to use I use standard scaler for to scale the data. We have to scale the data because of if there are different intensity of numbers, as we can see there is a maximum number is different for everyone, and if you keep the same things as it is, then what will happen, the intensity of one numbers will impact the others. Means if one column have higher numbers, then it will impact that amount or machine learning model that it is more important, but it is not true. Every column is equally important, so we use standard scalar so that every the number intensity will be reduced, and the columns will be fairly treated. After that, we split the data uh, into the training and testing parts with the test set 0, 1, 5 and random state equals to 0. After that, prepare a decision tree classifier for to predict. Then I import the decision classifier and then train it, and then predict it, and then find out the accuracy, which gives me 93.06% accuracy with decision tree, which is our task to predict. But I also calculated with some other algorithms like k neighbors, which is gives me 98.61% accuracy, which is the highest one. After that, random forest with n estimators 500, which gives 97.22% percentage accuracy, which is also nice one. And after that, logistic regression also gives 98.61% accuracy. So the overall summary would be decision tree definitely gives better 93.06% accuracy, but k neighbors and logistic regressions are the winner of this race with the 98.61% accuracy. So that's it of my internship work.